Hi, I'm Emily Stevens.
And I'm Molly Nikodem.
And today we'll be presenting our MIT App Inventor games, Tic-Tac-Toe and Balloon Tap. We will walk through how the apps are designed, how our code works in the background, and what programming concepts we used.
The first game is the Tic-Tac-Toe app. This app lets two players compete in a classic 3x3 tic-tac-toe match. It tracks turns, detects winners, and resets automatically. Our screen includes a title, a label showing whose turn it is, a label that displays the winner, 9 buttons arranged in a grid representing the board, and a reset game button. This is how the code works. We have global variables that are used to store game information. Our current turn tracks if it's X or O, our winner stores the game result, and the board list is a list that contains all 9 space buttons. This lets us update and reset the board efficiently. Then we have button interaction. All 9 buttons share the same logic. When a space is clicked, the button text becomes X or O depending on whose turn it is. The button is disabled so it cannot be tapped again. The turn switches, the turn label updates, and a winner checking procedure is called. This is the turn switching procedure. To avoid repeating code, we made a switch turn procedure. If it's X, it changes to O, and if it's O, it changes to X. It updates the turn label each time. This keeps our program clean and reusable. This is our winner detection logic. This is the core of the Tic-Tac-Toe app. We compare the text on button combinations to check all 8 winning conditions, 3 rows, 3 columns, and 2 diagonals. If the 3 matching symbols appear, the winner label updates, the input stops, and no more moves are allowed. This is our reset game. When reset is pressed, all button text clears, all buttons become enabled again, the winner label resets, and the current turn resets to player X. Because we stored the buttons in a list, we only needed 1 loop instead of repeating the code 9 times.
Our second game is Balloon Tap. Balloon Tap is an upward movement reaction game. The goal is to tap the balloon before it reaches the top of the screen. This game includes a score label at the top, a balloon sprite that rises upward across the screen, a sky background image, a reset button that shows up when the game ends. How the code works. Global variables help us create this game. We created 2 of them, balloon speed and score. Balloon speed controls how fast the balloon rises, and score tracks the taps. During screen initialize, score is set to 0. Balloon speed is set to 300, and score label is updated to show 0. A clock timer controls the animation. Every time the timer ticks, balloon Y is decreased by balloon speed. This moves it upwards. The app checks whether balloon Y has reached the top. If balloon Y reaches the top, Y is less than or equal to 0. Then timer stops, balloon disappears, the game over message appears at the top of the screen, and the reset button becomes visible at the bottom of the screen. This creates the rising balloon effect and losing conditions. The logic behind the game is when the balloon is tapped, the score increases by 1. The score label updates, the balloon moves to a new random X location, the balloon is reset back to the bottom by setting Y to screen height. This creates continuous gameplay where the balloon rises again for another attempt. The reset function is when the reset is tapped, the game over message clears, reset button hides, balloon becomes visible again, balloon repositions randomly, score gets reset to 0, and the timer turns back on. This resets the game smoothly.
This is the instructions button. It appears at the bottom of the homepage, and when it's clicked on, it will take you to a new screen which will show you all the instructions for balloon tap and tic-tac-toe. The research sets the game smoothly. We used ChatGPT and Google to help us create this app. In conclusion, both projects help us understand how games operate behind the scenes. Tic-tac-toe taught us logic, checking, and turn handling, while balloon tap showed us animation, scoring, and randomness. We enjoyed building these apps and learning how code and design interact. Thank you for listening.